Hello, welcome back. Today we're going to look at expected value or expectation. To start off, if we have a discrete random variable, that is if x is a discrete random variable, then it would have a corresponding probability mass function. In that case, the expected value, the formula of expected value would be something like this. Summation over all the x values of x times its corresponding probability. Let's look at an example. So here we have a probability mass function. Can have three values, 15, 25, 50, and their corresponding probabilities are 0.2, 0.5, and 0.3. So just to make sure it's a corresponding probability mass function, we sum up the probabilities and we see that they sum to 1. So it is valid. So let's go into calculating the expected value. So in this case, expected value of x would be, so the first value of x is 15 and its corresponding probability is 0.2 plus the second one is 25, its corresponding probability 0.5 plus 50, corresponding probability 0.3. So that's it. You just take the value, multiply it by its corresponding probability, and then you add up that for every value of x. So let's quickly solve for this. That would be 3 plus 25 times 0.5 would be 25, 12.5 plus 50 times 0.3 would be 50 times 3, 150. So that would be 15. And then adding that up, it would be 15.5, 30.5 would be your expected value. Moving on, if you have a continuous random variable, in that case you would have a probability density function, and in that case the expected value would look something like this. It would be the integral from negative infinity to infinity x times the probability density function dx. So yeah, because it's continuous, you would have to do an integral since you cannot really do a summation. Let's look at an example. So here we have a probability density function f of x, whose value is 12x times 1 minus x whole squared when x is between 0 and 1 and 0 otherwise. So the first thing you would probably want to do is check if f of x is valid. So you would want to do the integral of f of x from negative infinity to infinity. And see that it's equal to 1. I'll leave that as an exercise for you all. So yeah, I'll just directly go into calculating the expected value. So expected value of x, so the formula was negative infinity to infinity x f of x dx, and if you look at the function, it's only like the x values are only sort of valid between 0 and 1 and everywhere else is just 0. So I can change these limits to 0 and 1, and then I can put my f of x here, which is 12x 1 minus x whole squared dx. Now let's solve for this. That would be integral from 0 to 1, so that's going to be 12x squared, and then opening that up, it would be a squared plus b squared minus 2ab. So it's going to look something like that dx. So expanding that, that's going to be 12x squared plus 12x to the power 4 minus 24x cube dx. So that's going to be 12x cube over 3 plus 12x to the power 5 over 5 minus 24x to the power 4 divided by 4, and that's going to be between from 0 to 1. Let me just simplify this slightly. So now putting the limits in, what you have is, so we first put in the 1, substitute plug in the 1 for x, so it's going to be 4 plus 12 over 5 minus 6, and then minus, then we plug in the 0, and that's just going to be 0 because yeah, if you plug in 0 for the x's, the whole thing is just going to be 0, so I'll just write 0 for that. Solving for the final answer is going to be minus 2 plus 12 over 5, which is minus 10 over 5 plus 12 over 5. That's going to solve to minus 2 over 5, which is your final answer. Alright, so that was expected value. I hope you all enjoyed the video, and I will see you next time.